Bridge webinar. I'll keep my remarks short. Welcome. Thank you all for participation. As a couple of weeks ago, questions, comments, use the chat function. That will be monitored throughout the course of the presentation here. Also, everyone here, please put in the chat there your, make sure we get your correct email address so that we can send you the certificates. This, like the last one, has been awarded one Forrester CEU at category 1. Please also, and if you're in attendance, please send an email to Cindy Pascal at the University of Maine. I'll type her email address in the chat box. And I guess that's probably it for now. Stay tuned for other announcements. Future webinars, we'll try to put together some more so we can all get our learnings and plus get our credits. So with that, Dr. Michael Barker, I will turn it over to you, sir.
All right, thank you, Ray. Do you see the screen?
Yes, sir.
Good deal. Hey, and I even have a little red dot in case we need to circle something over there too. Well, like Ray said, I want to welcome you to today's Council on Forest Engineering webinar. This is the second that I've been asked to give. The last one was on January 15th, where we talked about bridge economics and life cycle costs of steel and concrete bridges. So as a starting point today, I'm going to make a little statement that we know that steel bridges meet owners and the public's desire for economy, aesthetics, and performance. Here, several bridge projects from prefabricated bridge manufacturers will be highlighted to demonstrate the merit of different types of manufactured steel bridge solutions. In this presentation, we're going to look at a showcase of bridge case studies that these manufacturing firms can design, build, and deliver to your bridge site. Bridge manufacturing firms use experience and economies of scale to produce high quality, beautiful, functional, and economical bridges for owners across the country. Many of the examples we will look at would also qualify as accelerated bridge construction projects, as we will see here in the case studies. So this is one of my favorite presentations, and I kind of call this, hey, let's look at some really cool steel bridge projects. It is meant to be a fun showcase of bridges that are available to us as owners and engineers from our steel bridge manufacturing industry. We will look at case studies from manufacturing firms that are members of the Short Span Steel Bridge Alliance. Now, you can get more information about any of the firms, of course, through an internet search or from the Alliance website, which is shortspansteelbridges.org. Now, some of the case studies we're going to look at and some of the videos we're going to look at are going to seem like marketing for particular bridge manufacturing or fabrication firms, as we mentioned their names and their products. And I admit it probably is. And if they get some business because of this, good for them, because they really do have some great bridge products. So in the January 15th presentation, we saw that the Short Span Steel Bridge Alliance is a group of bridge and buried soil structure industry leaders who have joined together to provide educational information on the design and construction of short span bridges. And I encourage you to visit that website because there's so much information there for the general person who's interested in bridges. The manufacturing firms are one type of member from the Short Span Steel Bridge Alliance group of stakeholders. In the context of this presentation, prefabricated bridges are structures that are designed and fabricated by manufacturing firms and delivered to the site ready for erection. Some people call them pre-engineered bridges, but that's not entirely true since each bridge is individually designed and fabricated for the particular site and load characteristics. Most of the examples we're going to look at and most of the prefabricated bridges for manufacturers are also applicable for accelerated bridge construction. They are built into components or modules and assemblies in a quality-controlled shop, shipped to the bridge site, and erected. This results in time savings for construction, cost savings, increased site safety, and the pieces will fit together because of the quality shop fabrication. However, another way to look at them is that they are a bridge in a box, in that the manufacturers worked out all the design and all the details, sent it to the site, and the owner gets an aesthetically pleasing bridge without having the inconvenience of going through a typical design, bid, build process. So now for the showcase. We will start with and I don't know New Orleans talk, but I'm going to call it the Bouquet Street Bridge in Gibson, Louisiana, that replaced a 5-span concrete deck bridge supported on piles that was constructed in 1962. The prefabricated panel beam bridge replacement was 90 foot long with two 12-foot travel lanes. Acro, out of Parsippany, New Jersey, fabricates standard 6-foot wide panels that are placed side by side for variable width bridges. For the Bouquet Street Bridge, the panels were shipped to the site and Gray Contracting erected the bridge. The standard bridges are fabricated for quick installation with minimal labor and no field welding, cutting, or field fabrication. The bridge modules are fabricated with pairs of girders, here with a steel orthotropic deck that had a factory-applied epoxy aggregate non-skid surface. All of the steel was galvanized for long-term protection. The modules were shipped to the site and set on the supports, and the orthotropic decks were bolted together for quick installation and no concrete curing time. And then the guardrails were bolted to the exterior girders. The Acro prefabricated panel bridges provide a simple design, quick installation, a long-lasting life expectancy, while meeting and even exceeding AASHTO load and design requirements. The Bouquet Street Bridge shown here uses an orthotropic deck and steel guardrails, but the standard panel design can also use timber decking or cast-in-place concrete deck, and of course jersey-type barriers. Prefabricated modules are built in the shop, shipped to the site, and simply connected together for a good-looking quality bridge. A simple concept combined with quality fabrication and practical erection planning, resulting in a great bridge product. For our next case study, this corrugated steel plate buried steel bridge, it's an arch bridge, right? Was built on Route 2B in St. Johnsbury, Vermont. The bridge was fabricated and designed by Big R Bridge in Greeley, Colorado, and built by J.P. Sicard. The bridge is located on a steep, or the old bridge was located on a steep, narrow site on a curve with residents living nearby. There were poor soils at the site, so the designer needed a system that could accommodate significant differential settlement. Limiting the number of days the trail would be closed and constructing the bridge before the peak summer and fall seasons was the priority. The contractor had a maximum 50-day closure of the roadway, but earned a monetary incentive when it was reopened after only 45 days. This was an ABC project, and it used precast concrete foundation blocks and precast wall panels to significantly shorten the construction time. And then, of course, there are no concrete curing times. So how are these things built? Stacks of corrugated structural plate are shipped to the site and bolted together to make arches. Then light equipment can be used to lift those arches and connect them together across the width for stabilization. And then the bridge arch is covered with soil and the roadway built. So this is the first video, and it's going to show you how a single arch is lifted and placed on the foundations by light equipment. Now I did speed it up 4 times because, okay, I will admit this is a pretty boring video. Just showing a couple excavators lifting an arch. But it does show how easy these bridges can be constructed out in the field. Okay, this is really exciting. I promise you, I have better videos coming up. So a buried steel bridge is lighter weight, flexible, and able to handle anticipated settlement better than conventional bridges. With the lightweight structure, they were able to use those precast footings. Because of the arch, shorter spans are required to achieve vertical clearance requirements. And there is a continuous road surface with no bridge deck or joints to maintain. Plus, and I say this every time I talk about this bridge, I think they are just beautiful bridges. Okay, so a fairly new concept for multi-bridge replacement plans is using public-private partnerships and bridge bundling programs. Recently, the Pennsylvania DOT Rapid Bridge Replacement Project involved the design, construction, and maintenance of nearly 600 bridges. The folded steel plate girder system from CDR Bridge Systems out of Pittsburgh was used on 7 of the accelerated bridge construction projects. In each case, the folded steel plate girder construction was completed with closures of only 30 to 35 days. This example, the JV70 bridge, is one of those that was constructed by Walsh Construction. The modular system, installed with ABC, saved time and inconvenience to the public. The units are fabricated in the controlled conditions of the shop, pre-topped with a concrete deck, here from AC Miller, shipped to the site and placed on the abutments. The folded steel plate girder bridges utilize cold bent steel plates to form an innovative girder shape that provides strength with lighter weight. Concrete deck panels are precast and attached to the girders to form composite units that can be shipped and erected easily and quickly. Instead of a more expensive, like ultra high performance concrete deck joint between the units, a simpler and wider high strength concrete closure pour connects the deck panels to complete the superstructure system. The erection of the 2-lane bridges with 4 folded steel plate girder units was completed in 1/2 of a work shift on all 7 of the bridges furnished by CDR for the PennDOT bundled projects. Now, I'm going to admit, this is a marketing video from CDR, but it also shows the folded plate system and the ease of erection. Okay, so now you've been marketed, but that's the CDR system. Another form of the economical bent plate tub girder is the press brake tub girder. This bridge in Mercer County, Pennsylvania, was designed by Construct out of Wyoming, Michigan, and fabricated by Valmont Structures out of Omaha, Nebraska. The bridge was built by Jet Excavating. So it was determined that there was a total weight limit for the existing abutments, and the lightweight press brake tub girder bridge met the load limits for the existing abutments, so no new abutments were required for this replacement project. Now, the Construct system utilizes 2 methods of installation: pre-deck modular units and field assembly. The pre-deck method is where the modular units delivered to the site already have the concrete deck on the girder units. The field assembly method delivers the cambered, galvanized, press brake form steel tub girders to the project site separately from the precast deck panels for site assembly. So due to the constraints of this project site and the equipment lifting capabilities of the contractor, it was decided the most efficient method of installing the new superstructure would be the field assembly method using full width precast concrete decks with grouted shear stud pockets for composite action with the tubs. The galvanized press brake formed steel tub girders were delivered to the construction site and installed on the existing concrete abutments. 8 precast deck panels were delivered to the project site and installed on the new press brake formed steel tub girders in one day. Then over the next week, the shear stud pockets in the precast concrete deck panels and the transverse deck joints between the precast concrete deck panels were filled with high-strength polymer concrete. The concrete curbs were cast concrete and the steel guide rails were installed on top of the concrete curbs. This video shows the erection of a modular press brake tub girder bridge.
Construct utilizes components of precast concrete and galvanized steel to deliver a highly durable and cost-effective option for building new bridges or replacing old ones. Construct bridges can be designed with precast foundations and include a precast concrete bridge deck to completely eliminate the need for concrete forming, finishing, and curing in the field. The strength and durability of the bridge system continues with cold bent steel tub girders, which have been researched and tested by both Michigan State and West Virginia universities. These highly efficient girders meet all AASHTO LRFD requirements and offer an unmatched shallow superstructure depth for crossings in hydraulically sensitive areas. All girders are hot dip galvanized, minimizing corrosion and further extending service life. Ultimately providing over 60 years of maintenance-free protects the prefabricated bridge units are delivered. The Construct system allows bridge elements to arrive fully assembled with the driving surface already installed, or be shipped in pieces for a contractor or county agency to assemble themselves. Upon placement of these bridge segments, individual units are secured together by an ultra-high performance concrete connection. Finally, sidewalls are formed and poured on site and guardrails are attached. The final approaches are then completed, allowing the new bridge to be put into service and the road opened.
Now you can tell my videos have a few jumps in them, and that's because I've taken these people's marketing videos and I've shortened them because I know millennials only have about a 90-second attention span when they're looking at a video, so I had to get them down. And you didn't want to look at their full marketing videos. So continuing with the press brake tub girder, here's a special case. This press brake tub girder bridge was a replacement for an existing bridge in Muskingum County, Ohio. This bridge is special because the tubs are composite with a sandwich plate system deck that is only 2 inches thick. The result is a low profile bridge that did not require extensive approach work, even though they were increasing the hydraulic opening for the crossing. The tubs were bent in a press brake by Mako out of Ellsworth, Kansas, and fabricated by U.S. Bridge out of Canton, Ohio, with a sandwich plate from SPS North America out of Banks, Oregon. And then finally, the steel was galvanized and metallized for long-term performance by AZZ Galvanizing. So you take a flat standard piece of steel plate and you bend them in a press brake. And then they're galvanized. Now this sandwich plate is only about 2 inches thick, made from steel plates sandwiching a polyurethane elastomer core. That is attached to the girders. And then the girders are put on the truck and shipped to the site. And here's a video showing just how easy the bridge was to install on the abutments. Oops, I hit the wrong thing. So the bridge was erected from one side due to the light weight of the modules in 20 minutes. There was excellent match fit and dimensional accuracy due to the shop fabrication and, of course, the sandwich plate quality. There was no concrete, so no curing time, and the bridge had immediate load carrying capacity. And the locals appreciated the 30-day road closure with the ABC modular bridge. Next, we're going to look at a prefabricated modular beam bridge, a common erection technique from our bridge manufacturing firms. Two beam elements are fabricated in the controlled conditions of a shop, shipped to the site, placed on the abutments, and connected together. This project is located in southern Indiana. The existing bridge was a narrow, deteriorating, two-span bridge with a total structure length of 35 feet. The bridge was replaced in preparation for a large roadway widening project. A 36-foot 8-inch simple span prefabricated modular rolled girder superstructure was selected for the replacement, which of course then removed the center pier. The bridge modules were prefabricated by Contact Engineered Solutions out of Westchester, Ohio, and the contractor was Civilcon. The new bridge was built with 3 modular sections that were shipped on one truck to the site. The modular sections consist of 2 weathering steel rolled beams with a pre-attached corrugated metal deck. Bolted diaphragms connected the beam pair modules after they were set on the abutments. Concrete deck was cast in place and a galvanized steel railing finished this bridge. This video shows the building of this bridge. The superstructure package was designed and built so the local county bridge crew could install the bridge. So there's no contractor. Within 6 hours of delivery, the superstructure modules were installed and ready for deck reinforcement and the concrete. Now for another structural plate buried steel bridge. The Montgomery County Department of Transportation began construction of an extension of Century Boulevard in Germantown, Maryland. The extension crosses a tributary of the Little Seneca Creek. The structure is a 41-foot, 4-inch span, low-profile steel structural plate buried steel bridge with an 11-foot, 9-inch vertical clearance. The steel corrugated arch includes continuous longitudinal stiffeners, ring beams for reinforcing ribs, concrete headwalls to support the severe skews, and a 14-foot wide concrete footers on each side of the arch. Lane Enterprises out of Camp Hill, Pennsylvania, designed and fabricated the buried steel bridge, and Francis O'Day built the superstructure. The Century Boulevard Bridge is a wide structure. In addition to 4 lanes of highway traffic, the 130-foot right-of-way accommodates a pedestrian walkway, a bikeway, and future transitways that will facilitate a 15-mile extension of the Shady Grove Metro line. With 4 foot of cover on one side and 12 foot on the other, the structural plate arch culvert is designed to safely withstand highway truck loading and design railway loads. The arches are shipped to the site in stacks of curved plates, bolted together to produce arch and lifted into place with light construction equipment. Without the shipping limitations associated with large conventional corrugated pipe, and because of the increased thicknesses and stiffener corrugations in the plates, steel structural plate is a viable alternative for significant bridge crossings. A buried steel bridge, this is kind of a repeat of what I said before, but a buried steel bridge is lighter weight, flexible, and able to handle anticipated settlement better than conventional bridges. With the lightweight structure, foundations are usually smaller and less expensive. Because of the arch, shorter spans are required to achieve vertical clearance requirements. And there's a continuous road surface with no deck or joints to maintain. Moving on to another example of a modular rolled beam bridge. The existing Swamp Creek Bridge, located in Sweetgrass County, Montana, suffered from high water events and scouring issues. So 8-foot wide by 65-foot long twin beam modules were fabricated by True North Steel out of West Fargo, North Dakota, and the bridge was constructed by the local county crew. The modules had a pre-installed guardrail and corrugated metal deck for a gravel roadway. This bridge also used accelerated bridge construction abutments. True North's prefabricated steel box supersill abutments, an ABC abutment, were shipped to the site and installed prior to delivery of the bridge modules. Starting in the morning, the local county crew and a crane set the 3 8 by 65-foot bridge modules by lunchtime that day. This video shows the construction of the Sweetgrass Bridge.
Swamp Creek Bridge for Sweetgrass County. It's a 24-foot wide by 65-foot span, pre-engineered modular steel bridge designed and fabricated by True North Steel. This particular job utilized the supersill abutment system, which is a steel box form that consists of structural elements, and once set and installed, is filled with concrete. The supersill abutment is typically utilized in situations where the soils are conducive for a perch style abutment or a spread footing. Modular steel bridges are simple to install based on showing up in component form and simply bolting adjacent modules together to achieve your width and length, and utilize a steel back wall to protect each end of the bridge and provides a decent place to build your road approaches. True North Steel modular bridges seamlessly tie together the most important aspects of bridges, including aesthetics, cost, and installation time. Our durable, prefabricated, high-quality modular designs are low cost and can meet AASHTO, state, and local bridge design requirements. We ship them prefabricated directly to the projects so they easily can be assembled and installed by contractors or county crews, resulting in minimal road closure time.
So again, you've been marketed a little bit there, but it is a neat bridge. True North's bridge package was selected based on economics and the simplicity of the prefabricated modular design that could be placed on the abutments and bolted together. With a gravel riding surface on the corrugated steel deck, the bridge was open to traffic within a day and a half from when the first prefabricated bridge module was set. Here's an example where the choice of material met a need in the effort to replace a bridge in an emergency using accelerated bridge construction. Rain flooding took out several bridges in Buffalo County, Wisconsin, including this Sheps Valley Bridge, which connects a state highway to about 20 homes and production farms. The emergency replacement was in the winter months, so concrete curing would be problematic. Wheeler Bridge from Minneapolis, Minnesota, designed a steel rolled beam bridge with timber decking and steel and timber substructure so that there was no need for concrete on the bridge. And then the bridge was built by J.F. Brennan. The substructure was built with driven steel piles and a treated timber abutment. The superstructure was rolled beams with simple cross-frame diaphragms. A timbered deck with an asphalt overlay was installed. And finally, a crash-tested railing system was installed. No concrete was required. The project delivery was nearly 3 times faster than the DOT method of design bid build. The use of steel beams was a key component in the expedited project delivery. All components could be erected during an emergency during the cold winter months because no concrete was required. Now, several of the manufacturing firms have standardized truss designs that they prefabricate, package, and deliver to a bridge site. So after Hurricane Maria in Puerto Rico, many crucial bridges were washed away and whole communities were isolated from civilization. U.S. Bridge has several standard prefabricated bridge designs that they shipped 5 of their Liberty bridges over a 6-week period to Puerto Rico, amounting to 800 metric tons of steel for over 950 foot of bridge length. This bridge is the Morovis Liberty Bridge, engineered and fabricated by, of course, U.S. Bridge, and erected by the Del Valle Group. The Liberty Bridge can be shipped as modules in containers, quickly assembled and erected, and can be used as a quality permanent bridge as they were in Puerto Rico. This particular bridge, out of the 5 sent, was a 24-foot wide, 3-span continuous truss with spans of 106, 98, and 106 feet, weighing 318 tons, and it was shipped in 17 containers. The steel was galvanized for longevity and low maintenance. This video, it's rather short, but I think it's really cool because they're putting together a 3-span continuous truss bridge with a crane. Truss parts and modules were shipped in containers to the site, sub-assemblies bolted together and lifted into place, and a riding surface installed. The Morovis Liberty Bridge was constructed in 18 days. All 5 of the U.S. bridges sent to Puerto Rico were completed in 6 weeks. And then a local resident stated, "What helped us the most was the construction of the metal bridge as they were dealing with the after effects of Hurricane Maria." Our manufacturing firms, with their innovative prefabricated bridge systems, can meet any bridge need and deliver bridge projects for owners. For our next manufacturer bridge case study, we will again look at a modular rolled beam bridge, one that is a little bit larger in size than the others we have seen. Many of the manufacturers produce standard modular bridges, and these bridges are being built all across the country due to economy, quality, ease, and speed of construction. The Sevier River Bridge, located approximately 2.5 miles east of Axtell, Utah, is a critical thoroughfare for the numerous farmers and ranchers in central Utah. The existing 1935 built bridge, shown here on the left, was structurally and functionally deficient and could no longer handle the load safely. The new 75-foot long bridge was built with modular rolled beam units using accelerated bridge construction techniques. The bridge modules were designed and fabricated by Wheeler Bridge out of Minneapolis, Minnesota, and the contractor was Gerber Construction. The new bridge was designed with 4 longitudinal weathering steel beams. The beams were prefabricated in modular pairs at Wheeler and shipped to the site for quick erection. Simple bolted diaphragms connected the beam pairs after they were set on the abutments. Concrete deck was cast in place and a crash-tested prefabricated steel railing finished the bridge. And here's the video.
while it was on here unstrapping, we made sure our abutments were cleaned off, ready to go. We had laid them out to make sure that we knew where the beams were gonna sit. Picked it off, set it down on the ground to get our safety horizontal lifeline on there so we wouldn't have to get out on the beam. We got that in place, picked it up, swung it over. We set it into place where the beams were supposed to be. And we'll start getting these diaphragms. There's 4 diaphragm beams that we need to bolt onto the first sets of beams. We'll get those bolted into place. Then we will pick up the second set of beams and move it over towards the first set of beams to line up with those diaphragms. We'll set it down, mark the anchor holes on this one, then pick it back up, drill those sets of holes, clean those out, and then set it back into place and bolt the diaphragm beams up to the new section of beams.
Now, according to the project engineer, quote, "We specified prefabricated steel on this project for several reasons. One reason was that steel beams are typically shallower than prefabricated pre-stressed concrete systems, which allowed us to keep a low bridge profile height. The second factor was cost. The prefabricated steel beams were less expensive than comparable prefabricated concrete systems." So this was a larger, traditional type rolled beam bridge that was modularized. That's a tough word to say. In the design, planning, and erection techniques to meet an accelerated bridge construction need. Our final case study will be a traditionally fabricated rolled beam modular bridge built as a bridge replacement project for State Road 30 near Pittsburgh, Pennsylvania. The contractor was Bremen Construction out of Saxonburg, Pennsylvania, and the modular units were fabricated by Quality Bridge and Fab out of West Middlesex, Pennsylvania. The precast deck was cast onto the modular units by Bremen Precast. The project included the demolition of the old structure, replacing the abutment stems and approach slabs, and constructing the superstructure with the modular units. The single span structure was replaced using accelerated bridge construction methods. Working 12-hour shifts, the old structure was removed and the new one installed in 57 hours. The road was closed Friday after rush hour and open Monday morning before rush hour. The beams were 54-foot long W30 by 99s with simple channel cross-frame diaphragms. The modular pairs were assembled and the deck was cast during fabrication. Then the modulars were shipped to the site and set. Ultra high performance concrete was used for the closure pores between the modules. So this is one of my favorite videos. It does not have sound, so I guess I'll talk us through it. So they close the bridge and they come in and they start unstitching that bridge. Then they take that bridge down, clear it out, and they come in and they have the abutment walls ready to be rehabilitated. So they're working on the stem walls there. They're also doing the work on the approach slabs when these modules first come in, and they pick up that first module with a hydraulic crane and set it in place. Then they get rid of that hydraulic crane and bring in a larger crane to put in the middle pieces. I wish they would have moved that hydraulic crane because it's kind of in my way of seeing things. But they just put these modules in, and while they put them in, then people start doing those closure pores between the modules. They continue working on the approach slabs. They get a little rain during this. And then they're finishing up the bridge. With minimal disruption to traffic, the old bridge was removed. The new bridge was ready for traffic in 57 hours. To me, that's quite an engineering feat in a busy part of that city. So that was our last case study, and now I'm going to summarize. I'm going to finish where we started. We know that bridge designers, fabricators, erectors, and contractors have always been innovative in delivering bridge projects for owners. Bridge manufacturing firms can deliver high-quality, beautiful bridges that are economical due to economies of scale and efficient, repeated fabrication practices. Most of the prefabricated bridges from manufacturers are also very effective for accelerated bridge construction. Owners and design engineers can find more information on these manufacturing prefabricated bridges and more bridge examples on the Short Span Steel Bridge website, shortspansteelbridges.org. If you need a bridge, these firms can design, fabricate, and deliver a bridge that meets your needs. So that concludes the webinar on January 29th, 2021 for coffee. I thank you for joining me on this Friday afternoon. Stay safe, and we will answer questions.
Dr. Barker, this is Dan Snyder. Can you hear me?
I can.
Can you go back to the slide with the Acro Bridge?
Oh, way up to the beginning. If my thing will follow that fast. This file is like 800 megabytes big because of all the videos and pictures. Oh, there we go. There's the Acro Bridge.
Okay. Actually, I believe that there's a question on this one, and also it might have been the US Bridge one too, but kind of a question on temporary versus permanent structures. In particular, if there's similarities between these bridges and the old Bailey bridges that used to go into place. Can you comment on that?
You know, I'm a little bit young for the Bailey Bridge, but I do know a little bit about them. So the Bailey Bridge what was considered a temporary bridge, right? And so the same considerations for abutment and settlements and excuse me, fatigue and durability, you know, they weren't as deliberate in taking care of those considerations in those bridges than they are in permanent bridges, right? But there is it's a matter of what you're going to consider in the design for that bridge site. So this Acro Bridge or those prefabricated trusses that excuse me became permanent bridges in Puerto Rico. If you take care of those details, if you look at fatigue, if you look at settlement, if you look at abutment loads and maximum loads over 75 years instead of over a shorter time frame, those bridges become permanent bridges. And Acro, yes, Acro is known for has a big share of the market for temporary bridges. But they take some of those temporary bridges and they put them in permanent bridge installations. Like some of our case studies, they actually have Tinker Toy type bridges, you know, where they literally come in a box and you put them piece to piece together with hand tools. And they've installed those as permanent structures. There's a real good example in Hawaii where they took that temporary bridge concept and turned it into a permanent bridge there. And so I hope that answers the question. I'm not sure it does to the full extent of what people are looking for, but that's about as good as I can do right now.
Okay, another question. We have to be a little bit careful on this because it has to do with price, and we have antitrust guidelines that we have to follow. But this is from Jay Hall. Jay said, I like the truss-sided bridges as they give more cross-sectional area by avoiding deep girders. But his question is, roughly, how much more do the trusses cost versus a girder bridge?
Well, that's an excellent question, but let's talk about the first part of that. Yeah, what does a truss do? it gets the load carrying superstructure above you instead of below you. And so that if you're crossing a creek that has a high water mark, if we put a beam bridge in there, we have to keep those beams out of that water, which means our road surface has to go up, which means our approaches have to get longer and higher, which means we have lots of cost. Okay, so now let me talk about the second one. Now, Dan's already said we have antitrust rules that we can't talk about. One manufacturer prices against the other, but we can talk in generalities. When we look at a bridge project, we want to look at the whole bridge project. For instance, I just mentioned approach work. If we looked at just the steel that goes into the truss versus just the steel that goes into rolled girders, probably the rolled girders might be less expensive because of material and fabrication. But if we look at that whole project and if we're going to put a rolled beam in there and we have to build up those approaches, or we have to put in a longer crossing, those costs go up pretty quickly when you start doing that approach work. So what we recommend is that you look at the project cost and not just the superstructure cost. And then, of course, you've got the aesthetic part. Just like you said, what was your first line? I like the truss-sided bridges. I do too. And if I'm looking at a bridge that I want to be aesthetically pleasing and I like truss bridges, am I willing to pay a little bit more for that? Well, the answer may be yes. Of course, if you're on a minimum bid required project, maybe the answer is no. So there's a couple responses to that question, Jay. Total bridge costs is what we want to consider. Yep, trusses get that superstructure above you instead of below you, so you don't have to do the approach work. Yet, trusses may be a little bit more expensive than rolled beams. Let's look at it holistically at the total project.
Okay, thank you, Dr. Barker. That is that takes care of the questions from chat. I guess we can always open it up to anybody that wants to unmute themselves.
Yeah, feel free to turn on your microphones. We have a little bit of time here. If you want to turn on your microphones and just chat with each other, with us, feel free to do so.
We even talked a little bit before. If you have any upcoming projects, possibly have a question on, feel free. Here's your chance to ask.
This is Dave Wilcox from Vermont. I'm a watershed forester in Vermont. We do a lot of bridges. Yes.
Dave, Vermont
on state forest. Yes.
Vermont is the one state out of all 50 I have not been to. Why don't you invite me up there
to look at?
Why don't you invite me up there in the autumn to look at some of your bridges, and we'll do some maple syrup and we'll do a little fishing and we'll look at some bridges.
There you go. Consider yourself invited.
Okay.
But I do a lot of work on state forest highways, which are, truck roads in the woods. They're not, they're certainly short span. We get up to 40, 50 feet. But a lot of the companies that we've talked about today are not in New England. Is that, what can we do there? What's the best resource for determining, if any of these are viable alternatives for us?
Well, that is a great question. And the answer is you talk to them. I know these firms will go lots of different places. I mean, Acro is up by you. US Bridge is not far away. Contech and Big R Bridge, they send bridges all over the country. It might be a case of there just hasn't been enough communication yet. And if you had a bridge project, let's say you need to cross this 40-foot Creek. There's a couple avenues you can take. You can go to the shortspansteelbridges.org website. We have what's called Eastpan 140. I don't know if you're on the December 15th webinar or not.
I was.
Oh, okay.
Yep.
And that could be a starting point just to see what kind of rolled beam bridge would fit your needs there. But also on that website are contact points for these different bridge manufacturing firms. And they, of course they would love to talk to you, right? They want to sell you a bridge.
Right.
And they're going to go out of their way to show you how their, again, quality shop built, years of experience, modular type bridges will fit your needs. And I know that because my son works for one of them now. I'm not going to tell you which one because that would show favoritism. But I mean, they would love to give you options for how to cross that, and it doesn't cost you anything to ask, and you can contact any of those people through the website. And again, like I said in the presentation, you can look them up on the internet and just say, hey, I've got this, what did I say, 40-foot crossing. Here are kind of the site conditions. What do you recommend? We're looking for a rolled beam. We're looking for a truss. We're looking for press brake. We're looking for anything.
Yep.
And they will respond because they want to sell your bridge, right?
Right. Do you know of any other places in the Northeast or that have used bridges like this for off public it's public land, but it's not a open 24/7 public bridge that we install. So do you know of any other folks using these bridges in that kind of capacity for
in the
forest roads?
In the northwest region of Coffee, we're working with them also, and I mean they're buying bridges out of Colorado and putting them up in Washington. They're buying bridges out of Canada and putting them into Washington. These prefabricated manufacturing firm bridges, and I just, Dan, can you think of any particular bridge projects that are going on up in that Northeast area?
Well, I'll tell you what, no, but Michael mentioned our website. Michael, I don't know if you could let me show my screen, or maybe you can go to the website.
Sure. Go ahead and share your screen.
Okay.
Well, let me make sure I let you. Yep, now you can.
Okay. All right. Can you see my screen?
Yep.
Okay. So right here on our website, shortspansteelbridges.org, we have this project assistance button. And really, for anybody on the call, it's a real simple form here on the right. And if you fill that out, and even in the message, you just write, I'd like to see some bridges in the Northeast that fit, whatever the specifics are you're looking for. What happens when you fill out that form is that comes to me, and then I send it out to 176 of our members, and they'll get back to you with, a bunch of different replies, specifically what you're looking for. So please feel free to use that, because that's the best and fastest way really to get in touch with all of our members. And then also this find a supplier section. If you're looking for a bridge fabricator or a coater or fasteners, we have about 70 companies that are part of our alliance on here. So for example, if you're looking for a bridge fabricator, you simply click on that. The first one that comes up here is Acro. They're in New Jersey. So if you click on, let's say for instance, Acro, there's your contact information, for someone, and that's their direct number that you could speak to. So through those two options, either project assistance or find a supplier, you can get information and you can get it quickly. But that's kind of a long answer to your question. No, I don't know of projects, but we can quickly find that out for you.
Yeah. Well, that's super helpful. We've gotten some bridges out of Pennsylvania, and this resource, this website would be excellent. We have, well, in some cases, the game we play is, you know, how much is it to build the abutments versus to stretch it out and have your abutments be high and dry and not next to the stream. And it all, you know, so there's a lot of variables that go into it. So I'm thinking of one bridge that putting in a squash tube, or not a squash tube, but an arch culvert, you know, the cost is $300,000. Whereas I think we could widen it out and get up and out of the water and have a longer bridge, but probably be less expensive than that. So thank you. That's very helpful.
Yeah, no,
Sure. Yeah, we'd be glad to help you.
That's a great question and discussion, Dave. And these people are looking forward to working with you, and they will come up with a solution. That's one thing that's impressed me in my years of work, because I'm a faculty member. I'm a professor. I don't design bridges. I don't, well, I guess I kind of market them today, right? I am kind of marketing them today, but you know, I'm not a contractor. I'm not a designer for these bridges. And it's really impressed me on how innovative these manufacturing firms are in meeting those needs. And there was a question on here: what is the length of the longest span considered a short span? So of course that's subjective. What we did when we started the Short Span Steel Bridge Alliance back in 2007 is we kind of said spans up to 140 foot are short span bridges. And that's kind of caught on in the industry. It doesn't mean if you have 150 foot, you couldn't treat it like a short span. And it doesn't mean that if you had a three, you know, you know, one of those crossings where it's a 30, 50, 30, that it's not a medium span. But in general, we consider 140 foot. You know, and our rolled shapes can get up to 100 foot, and then plate and then plate girders start at about 80 foot, maybe 70 foot, and go up to 140 foot. And then the manufacturers that we talked about today can give you solutions for those. Oh, let's see. Lewis said, Michael, are you familiar with this company in Brewer? And I did bring it up quickly, and I don't think I am. I don't, but I have the website up and I will look at it. I guess I could share my screen and show other people, but it looks like they do some arch type bridges and things like that. But no, I'm not familiar with them. Might be their concrete. Are those steel? Those are steel. Yeah, I don't know. Dan, maybe we need to contact them, see if we can get them into the fold. Oh, I'm sorry. Lewis sent to me that privately. I apologize, Lewis. I thought it was general, but I dealt with it here anyways.
You got one more question,
Jay asked about galvanizing and metallizing. Please explain the latter. Okay. Well, we know what hot dip galvanizing is. We put it in a big tub of zinc. It comes out and it metallurgically bonds, and it gives us years and years of maintenance-free performance, and we like galvanizing. But some things don't fit in the tank, right? Or some things have configurations where it's difficult to hot dip galvanize. And so the industry has come up with metallizing, and it's very similar. What they do is they take a gun and they take zinc or aluminum or zinc and aluminum, and they heat it up and they liquefy it, and they shoot it on the surface. And it's pretty much equivalent to hot dip galvanizing. It's a little longer process, but for instance, you know, well, I'm trying to think. Well, if we wanted to protect something that's 140 foot long with a zinc protection system, That doesn't fit in one of the hot dip galvanizing kettles. So an alternative is to bring in the metallizers, and you can go through that whole beam and metallize that thing, and get that same type of corrosion protection that hot dip galvanizing gives us. But it's a spray gun applied instead of a dipping. Maybe if I started there, that question would have been answered faster. Okay, well, it is past 11:30 my time, 1:30 your time. Again, I want to thank you for joining us. Dan and I do enjoy giving these types of talks. We have a whole range of topics that we give presentations, webinars across the whole country. That's one reason I've been to every state except Vermont, is because of the Short Span Steel Bridge Alliance. If you are interested to see some of the educational products that we do, they're on the website. For instance, starting here in February, Dan, can you bring that up quick?
Yeah.
I do a 6-part educational series, which is kind of targeted to students at universities, because a lot of universities don't teach bridge design, and to young professionals. But what I have found is that we have a lot of old professionals that really enjoy it. And we've given it we gave it several times last year. It is a certificate program. So at the bottom right, you see the certificate that you can earn by attending all 6 lectures and completing 6 quizzes that take you all of 3 minutes apiece. They're not technically advanced quizzes. And on the website is what Dan is showing on the screen there. We call it Steel Bridge Education Lectures from Concept to Delivery. It goes through the bridge industry. It talks about protection systems. It talks about software, not doing software. It is not teaching you how to design steel bridges. It's talking about the steel bridge industry and the bridge industry. And so you are welcome to go to the website, and it's easy to sign up. And they're Tuesday, Thursday, starting February 23rd and running through March 11th. We still have some room. I can take up to 300 people, and I think it only started being advertised a week or so ago, and we're up to about 180. So there's still room in it. So if you are interested in doing that, I certainly encourage you to do that. You will see this presentation again there, not in the same form, but similar. But there are 5 other lectures in there that people really enjoy. And those are a list of, nope, those are not. I don't know what Dan's doing now.
Yeah, so if you go to our website and just go to the homepage and go under About Events, you'll see all of the upcoming events, and the registration for the student Steel Bridge Education Lecture Series is here, February 23rd through the 11th, through March 11th. You just click on additional information, and it'll take you here with registration, course syllabus, and all of the information you need. So once again, just go to the shortspansteelbridges.org and click under on events under the About section.
Okay, well, Ray, I think it's time to wrap this up. It's Friday afternoon out there.
It is, Michael. Thank you very much. Mike and Dan, I appreciate your time. I appreciate you putting these 2 webinars together for us. I certainly hope all the attendees got what they were looking for. I really appreciate the additional information and the website and your contact information. This has been great. If anybody's got any questions, you can get hold of Dr. Barker or Dan, and they can help you out. You can send them to me too, and I'll do what I can to help you out. Stay tuned for additional programs, additional webinars. As everybody should know by now, we're not going to do our 2021 in-person meeting this March. Things just aren't quite right to be able to do so. So we're going to continue with our online sessions. I'll try to put together as many as I can. And with that, folks, please be safe, be warm, and we'll be in touch. Take care. Michael and Dan, thank you again.
Thank you. Goodbye, everybody. Stay safe.
Thank you.